All right, so before we get into 5.2, let's look at some 5.1 homework questions. Yesterday's homework. We'll start by looking at number 7. Number 7 says, find the product. Now, product means to multiply. And you're thinking, well, I thought we just divided yesterday. We did when we were finding unit rates, we were dividing. Here's why this one's being multiplied. You work 8 hours. You make $9 per hour. If I told you that you worked 8 hours and you make $9 per hour, what can you do with that information? You should be able to tell, you can multiply it, and that should tell you what? Not how much money you get per hour. I already know that's 9. How about how much money I get?
8 hours.
I already know it's 9. How about how much money I'll get for working 8 hours, right? So if I work 8 hours and I make $9 per hour, what happens here is that the H down here, the hours, cancels out with the H up there, other hours, and you're left with just a dollar sign. What I'm not going to label my answer in dollars per hour. I'm just going to get dollars. What's 8 times 9? Now, when I'm writing this in my work paper, I would just put a dollar sign in front of 72. What if I told you I'm buying 8 pounds of turkey and it's $3.50 a pound? You should be able to multiply that to see what you're going to pay for the turkey, right? Because what happens is the pounds cancel out. And so this right here is the unit rate. This right here was the unit rate. And I can use the unit rate to determine what my price is going to be when I buy 8 pounds of turkey. What's 8 times 3.5? 28 pounds, $28 again. Yeah. So what happens is the pounds cancel out just like the hours canceled out. And so you would just say you paid $28 for that much. So you can use the unit rate. I've circled the unit rate for you. You can use that to then find the price of whatever it is you're buying, how much you're buying. Numbers 11 and 12 and 13 and 14 and 15 all give you ratios or rates. They want you to write them as fractions and they want them to be simplified. Okay, so Ella, what fraction could I write for number, what did we look at first? Number 11, what fraction could I write for that? Okay, so I turn into a fraction. Remember, ratios can be written one of 3 ways. Fractions, most common. You could write the word 2 between the numbers, or you could use a colon. All of them are the same thing, but they all have to be reduced. So Ella, what do you think you could reduce 25 and 45 by? 5. Didn't you reduce fractions on your chapter 5 opener? Obviously, right? Let's do today. So yeah, so that's what you're doing for number 12. Write it as a fraction and reduce it. What's a number that can go into 63 that also would go into 28? 7. Nice job. 7. All of these will reduce when you write them as fractions. They will all reduce. So don't just leave them as their unreduced form. They will all reduce. Okay, I'm speeding along. I'm not just doing every question. I'm just going to give you a couple, right? Some examples to look at. Number 17 is the first one where it's asked us to find a unit rate. And what are we doing when we find a unit rate? What operation? Always division. Division will always give you the unit rate. Well, Mr. Bright, why did we multiply last time when we were up here? Because it said find the product. We used the unit rate to find a dollar amount. Now we're just going to find the unit rate. So this is what you need to put on your work papers. I don't need to see any long division, but on your work paper, you should put 180 miles, abbreviate. Really, you should be writing this down.
Yeah.
Get a piece of paper out. I suppose, if that's what you're actually doing. Write 3 hours on bottom. You can abbreviate. And then Branson, you're right. We do have to divide those. What's 180 divided by 3? 60. And then I can't just leave it as 60, guys. I know that your temptation is just 60 and move on. You are going to get marked off a lot on your quizzes and tests this chapter if you don't label, though. Everything needs a label. In fact, unit rates need how many labels? 2. So once I divide the numbers, I also have to divide the labels. And so what's my label going to be? Miles per hour. Oops, let's try that again. So divide the numbers and then divide the labels. And when you divide the labels, you pretty much just take that and twist it. You take the miles and then you twist that fraction underneath that fraction bar to make a slash, and then hours. That's it. Now, miles per hour, you can write MPH. Why can I not write an M today? You can write MPH. I got no problem with that. Just don't do that for all of them. Okay. You can't put, like I said, students per teacher yesterday, STP, SPT. You can't, that makes sense. No one knows what that means. So normally you'll use the slash when you write those. Do the same thing for 18. Do the same thing for 19. Miles per gallon, dollars per pound for each pound, dollars per can, words per minute. Parker? No, because nobody knows what that means. But you can use W/MIN. Okay, number 23. Use the ratio table to find the unit rate with the specified units. Here's the specified units, servings per package. We looked at problems like this yesterday in the notes. Remember we said we could use any one of the 4 ratios because they should all give us the same one. Maddie, into us, which one do you want to use? The first one. Okay, we're going to look at the first one. Okay, this is what's really important then. Servings per package. That's the order I'm supposed to divide it in. Servings on top, package on bottom, packages on bottom. Okay, Maddie, which of these is the servings number? The 13.5. So we have to invert it so that it makes sense. Not packages per serving, but servings per package. What's the package number for the ratio you chose? 3. You don't like the ratio she chose? You could do the same thing for any of these 4. They'll all give you the same answer. Go ahead and divide it, Maddie, and we'll see what our unit rate is. That's right. And label for me, 4.5. 4.5
servings per package.
Perfect. Servings per package. Got to have a label. In fact, got to have 2 labels. You can use any of those 4 ratios. Just what I'm afraid that you're going to do is you're going to forget that it said servings per package, and you're going to do 3 divided by 13.5 and some weird decimal. Make sure you're dividing the right order. It tells you what order to divide it. Servings, then packages. Number 25. At 1 p.m., you have 24 megabytes of a movie downloaded, and at 1:15 p.m., you have 96 megabytes. What is the download rate in megabytes per minute? That tell right there. Megabytes should go on top. The abbreviation for megabytes is a lowercase m and a capital B. I think that's right. Any computer nerds in here know if that's right? No, no one here, computer nerd. Okay. And then minutes, MIN. That's the order I'm supposed to divide it in. Now, what makes this problem interesting is they give you 2 different megabyte numbers. They said at 1 o'clock, I had 24 megabytes downloaded, and at 1:15, I had 96 megabytes downloaded. So in order to figure out what our speed is, we need to know how many megabytes we downloaded in that time frame. How do I determine how many megabytes were downloaded in that time frame? Thomas? Say it again. That's exactly what I do. Go ahead and do that for me. 96 minus 24. We started at 24. We ended at 96. I don't know if the movie's done downloading or not, but that's how much we downloaded in 15 minutes. How many megabytes did we download in that time frame? Nice job. We downloaded 72 megabytes in that time frame. Now, how many minutes went by? From 1 to 1:15 would be 15 minutes, right? So in a 15-minute time frame, we downloaded 72 megabytes of that movie. And so now we're ready to divide. Aiden, what do you get when you divide 72 by 15? Okay, and what's my label going to be? That's right. I'm all for abbreviating. You have to label. Okay, but I'm okay if you abbreviate with your labels. That's perfectly fine. Number 26. In 2007, the US population was 302 million people. In 2012 was 314 million people. What was the rate of population change per year? Population change per year. That's what we need to figure it out in. And so if you look, if you can kind of cheat down and look at the labels on big ideas, how did they label their answer? How did they do it, Ashland? Yeah, million people per year. So that's how I'm going to put my ratio. I got million people on top, and I got year on bottom, or years. Technically, it's going to be years because I'm going to figure that out right now. I need to extend my fraction over a little bit. Okay, so let's start by doing the same thing Thomas did in the last question, which is figuring out what our population grew by. Ashland, if it goes from 302 million people to 314 million people, how many million people of an increase is that? Yeah, 12 million people increase. And Rayleigh, if it went from 2007 to 2012, how many years went by? 5 years. Okay, Rayleigh, do 12 divided by 5 for us, and we'll have our unit rate. This is a rate. Oh, this is a rate, and we're going to make it a unit rate by dividing. 12 divided by 5. 2.4. Okay, you guys get that too? 2.4. What's our label though? Million people. Yeah, it's not 2.4 people. 2.4 million people, and I'm running out of room, so I'm going to do it like that. Million people per year. 2.4 million people per year is our average increase for that, our unit rate. And finally, we did one like 28 in the notes, so I'm going to scroll through and let's look at number 30. Number 30 would be really easy to do this one and not show any work, but I want you to show your work for this. So I'm going to show you what the work should look like. It says a sports store sells 3 different packages of tennis balls. Which pack is the better buy? Well, in order to find what the best price is, I need to find out what each pack costs as I'm doing this. This is the unit rate. By the way, if you go grocery shopping and you look at the barcode where the price is, there's usually a small number down in the bottom corner and it tells you like 9.6 cents, something like that. That's telling you what the unit rate is. They used to have calculators built in on the carts. There are some stores in Florida that I've seen that actually have the calculators built in on the carts, and you would calculate the unit rate yourself. That's when people were smarter than what they are now. I don't think there's too many people that if I said, hey, what's the unit rate, would know what to do. But now they just put it on there so you can see, okay, so when I'm comparing this soup with this soup, I can see this one's cheaper per ounce than what this one is, and I know which one I want to buy. I'm going to do the same thing here. So I'm going to pay $11.49. But how many packs of tennis balls do I get? Get 4 packs of tennis balls. Okay. Branson, I want you to find the unit rate on that. For the middle one, I'm going to pay $16.79. Parker, how many packs of tennis balls am I going to get? 6 packs for that one. Yep. Parker, I want you to find the unit rate on that. And then I'm going to pay $22.99 if I buy how many packs, Thomas? That's 9 pack. Yeah, Thomas, find the unit rate on that. Now, you need all 3 of these written down on your work paper. So Branson, what did you get for your 4 pack? Yeah, I don't have time to wait on you, Branson. I need you to use your calculator. Okay, we'll skip down to Parker. Parker, what'd you get for yours?
Hold on.
Okay, so 2 points. So we're going to round to 2 decimals because we're talking about money. Okay, so 2.798. Does the 8 bump the 9 up? Okay, so the 9 becomes a 10 and makes this $2.80. So I'm gonna spend $2.80 per pack. That's the deal I'm getting here. Branson, what'd you get for yours? Okay, that rounds to 2.87 per pack. That's more expensive. And then Thomas, what did you get for yours? What was it? 2.55, $2.55 per pack. Oh, that's pretty clear then what your better deal is, isn't it? If you buy in bulk, you will save more money. Now, is it more expensive? Yeah, overall it's more expensive, but you're buying more tennis balls. And so you're getting a better deal if you buy in bulk. That's why stores like Sam's Club and Costco exist. It's more expensive, but you're getting way more for your money. And last one, number 31, it costs $68 for 16 square feet of flooring. How much does it cost for 12 square feet of flooring? So this right here is a complete ratio. $68, write it down, for 16 square feet. I'm going to abbreviate that, feet squared. Ella, if I pay $68 for 16 square feet, what does each square foot cost me? That's right, $4.25 per square foot. It's kind of like the artificial turf problem we did in the notes yesterday. $4.25 for each square foot. Now, that's what I know it costs because I spent $68 on 16 square feet, so I can figure out what each square foot costs. I need to purchase 12 more. What's that going to cost me? How do I do that? If I know each one costs $4.25 and I need to make a purchase of 12, what do? I multiply that. And that takes us back to the first problem that we looked at in this homework. I'm going to multiply by 12 square feet. This square foot here is going to cancel out with this one on bottom there. So I'm just going to get a dollar amount is my answer. And what is my dollar amount? How much do I pay? I pay 51. Which makes sense because if I paid $68 for 16 square feet, I should pay a little less for 12 square feet. And so I can find my answer by finding out what each square foot costs and then just times that by 12 because I need 12 of those. So I found the unit rate and then I multiplied just like I did in the very first problem we did up here, number 7, where I found the unit rate was already given to me and I multiplied. Okay, you need to finish that homework for tomorrow. And now we're going to fly through, which may be the easiest section in the chapter, section 4.2. Please get the notes downloaded from Google Classroom. Give you a second to do that. While you're getting your 5.2 notes downloaded, just a reminder, the chapter 5 opener is due today by 2:30. So finish downloading those. And then we start off with actually a question probably that could have been in our notes yesterday. Determine if each scenario is fair or unfair and how can you tell? If I told you that you paid $184 for 2 concert tickets and I paid $266 for 3 tickets to that same concert, how would I know if that's fair or not? Okay, I would divide. What would that give me if I divided? Like anytime I divide, that gives me the what? The unit rate. You're exactly right. Yeah. So if I find the unit rate, I'll be able to tell. How did we tell if the tennis balls were a fair deal? Right? We had to divide them, right? We had to figure out where were we with the tennis balls. There you go. We had to divide, right? To see what each pack costs. Would you say that this is fair? Is each package the same all the way through? No. You buy more, you get a better deal. nice, but it doesn't mean means it's not fair. It's not each the same. So that's what I'm trying to figure out here. So what is $184 divided by 2 tickets? What's the price of each ticket? What is it? Not 92. Oh, sorry, no, it is 92. I'm thinking of the 266. You're right. So I paid $92 per ticket here. What about for the other one? What if I buy 3 tickets at 266? Maddie, what's 266 divided by 3?
8.66.
8 or 88?
88.666.
Okay. So we'll round that third one. Well, that third one will round the second 6 up to a 7. So if we're talking about money here, and so that's $88.67 per ticket. Is that fair? Did we get the same deal? We did not get the same deal. That is not fair, but that's pretty normal. Usually when you buy more, you pay more, but you pay less for each ticket. Well, sometimes, especially for food. For food, that's definitely going to happen, but usually not for tickets. What about this one? You took a quiz, you took a multiple choice quiz, and you got 75 points for answering 15 of the multiple choice questions correct. And then I get 70 points for answering 14 questions correct. Is that fair? Well, Ella, tell me what 75 points divided by 15 questions is. 5 points per question. Ashlyn, what's 70 points divided by 14 questions? 5 points per question. Is that fair? We took the same test, right? Should be fair. Yeah. And that, using that example though, I guess my tests aren't fair. Is each question worth the same amount? No, but everyone's taking the same test. In that sense, it's fair. But like, it would make sense for me to ask you to do a problem where I'm just dividing a unit rate and give you the same amount of points as a problem where you solved a multi-step equation, right? Like, more work should require more points. So, all right, so this is section 5.2. Now we're getting into it right here. Now let me say, and I want to make this very clear. Tonight's 5.2 homework only has yes, no questions. I will not give you any points if you complete it all on big ideas and don't turn a work paper in. No points. I will give you 0 points if you complete it on big ideas and turn a work paper in, but there's no work on the work paper. I'm only going to give you points if you show your work. Otherwise, what's to stop you from going through and clicking yes and clicking check answer? Oh, it's wrong, so no, and not learning a single thing. This section is easy, and even showing your work is easy, but you have to show your work. Okay, otherwise I'm not giving you any points. So don't be like, well, it says here I submitted it. Yeah, you did. You didn't turn a paper in, so I'm not giving you any points for it. Okay, so you have to turn it. This isn't 5 additional points added on. This is you get no points unless you turn the work paper in. No points. Now, that being said, let's talk about why I'm so big on showing the work on this section. A proportion is an equation stating that 2 ratios are equivalent. Remember, ratios are just fancy words for fractions. A lot of times we write them as fractions. 2 quantities that form a proportion are said to be proportional. So if I have 2 fractions that are equivalent and they're equal, I can also say that they are proportional. They are the same. You paid $2 for 3 donuts. I paid $4 for 6 donuts. That is the same. That's the same price. Yeah. So that those unit rates would be the same. That would be fair, right? Okay. So let me show you what tonight's homework is going to have you do. They're going to give you 2 ratios. And they're going to ask you, is it proportional? Yes or no. And so you have to show your work. And I'm going to give you 3 things you could do. You could pick any one. I'm going to give you 3 methods you could use. The first method you could use to see if 2 ratios or 2 fractions are equivalent or proportional is you could just reduce them and see if you get the same fraction when you reduce. Like I get the same fraction when I reduce. 4/6 reduces to 2/3. That's why I know they're equal. What about 6/8? What's a number that goes into 6 that also goes into 8? 2. Okay, so divide by 2. Parker, what's 6 divided by 2?
3,
And 4 to 8 divided by 2?
4.
4. Okay, so I get 3/4. That fraction reduces to 3/4. What's the biggest number that goes into 18 that also goes into 24? 6. Nice job. So Ashlyn, what's 18 divided by 6? And 24 divided by 6? Do I get the same fraction?
Yes.
So then, yes, they are proportional. That's what I'm doing. I'm just seeing if they equal the same thing, then putting yes or no. Parker? Sure. Maddie Cheeseman, what's the biggest number that goes into 16 that also goes into 20? 4. Okay, 16 divided by 4 is 20 divided by 4 is, okay, so 16/20 reduces to 4/5 if they're proportional. This other fraction will reduce to 4/5. Branson, what's the biggest number that goes into 9 that also goes into 12? Branson, what's 9 divided by 3? And 12 divided by 3? Do they equal the same fraction? No, they're not proportional. So that's one thing you could do. We just got 2 problems done. That's one thing you could do. You could divide them and see if you get the same fraction. I'll be honest with you, I dislike this method because as the numbers get bigger on top and bottom, it becomes harder to reduce them. So I like methods where I can use my calculator. Method 2, divide. Now I'm giving you the same fractions each time. So we know it's going to be yes, no, yes, no, yes, no. But I want to prove to you that you get the same thing. Now, what do you get when you divide a fraction top by bottom? When did we do that? We did top divided by bottom when we wanted to turn a fraction into a decimal. Yeah, so I should expect to get a decimal. Now, if I don't get a decimal and I get something like 5, that's okay. If I divide 25 by 5, I'm going to get 5. So sometimes you get whole numbers. What is 6 divided by 8? .75. Thank you. By the way, that's what 3/4 is equal to. So I know that that's correct. And what is 18 divided by 24? It's the exact same thing. That's a really easy way to tell that these are proportional. And of course, I knew they were going to be proportional because last time I did the reducing, they both are 3/4. So I know they're the same. Okay. What about 16 divided by 20? 0.8? 9 divided by 12? Yep, and remember they weren't the same, were they? So no, they're not proportional. That's an even easier way to tell. Method 3. Possibly even easier. Cross products. You guys remember using the butterfly method last year? Okay, so let me show you how to use cross products. What is 8 times 18? 144. Okay. And what is 6 times 24? Oops. 144. I'm getting the same thing, so they are proportional. That's my favorite way. What is 20 times 9? Anybody? 180. And what is 16 times 12? Was it 192? So then the answer is no, they're not proportional. So when I preface this lesson with you have to show your work or you're going to get no points, I'm not asking too much from you. I'm going to let you choose any of these 3 methods. I'll be honest with you, I don't ever choose method 1. I always do either method 2 or my favorite is method 3, cross products. Really easy to do. So what would I write on my work paper if I'm doing method 1? The reduced fractions and then yes or no. What would I write if I'm using method 2? Each decimal and then yes or no. And if I'm using cross products, write what both the cross products are and then yes or no. Or I'd even let you put an equal sign or a not equal sign as your yes and your no. Okay, because if they're proportional, that means they're going to be equal. Yes, sure. So this particular section is going to focus more on the cross products because we've already done division, turning fractions to decimals. And so you guys remember this from last year. Cross products is when you take the top number and the bottom number of 2 of those fractions and you multiply them. And then you take the bottom and the top number of the opposite fractions and you multiply them and you get something like this. Remember how we said we know 2/3 is the same as 4/6? Well, we can tell that because 2 times 6 is 12 and 4 times 3 is 12. Cross products will always give you the same answer. And if they don't, well, I guess they weren't proportional to begin with. So if they're equal, you'll get the same thing when you cross multiply. Example A. What's 1 times 10? 10. Why did that take so long? What's 5 times 2? 10. Are they proportional? Yes. So what I've just done, which is put 10, 10, yes, that's my work. Bless you. Example B. 6 times 18. What is it? 108. 4 times 24. Sorry, this is so frustrating. 96. Is 96 equal to 108? No, they're not proportional. Move on. 3 times 5. 15. 10 times 6. They didn't even have a chance to be proportional. Look at the two fractions. Look at the two ratios. One of them is a proper fraction, 5/6. One of them is improper. So there's no way a proper fraction and an improper fraction can equal the same thing. So that had no chance. And then example D, what's 20 times 15? 300. And what's 25 times 12? It's 300. So are they proportional? Yes. I'm not asking much, guys. I just want to make sure you're doing the work and not guessing. Does that make sense? So when your work paper, if you turn on a work paper and it just has 300, 300, yes, that's all I need. That's all I need. Okay, but show your work. Now, what do I do if instead of giving me 2 ratios, they give me 4 ratios? Well, I probably shouldn't use cross products. Cross products would be very difficult if I have 4 ratios. So what I'm going to do is I'm going to revert back to method 2. Method 2 told us to divide. So that's what we'll do anytime we have more than 2. So when we divide, we're not going to do x divided by y. We're going to do y divided by x. We're going to do y divided by x because typically when you have a problem like the one that we did here, it would be servings per package. You always remember how we inverted this one on the homework? We're going to invert all of them. Y is always going to go on top, which I know is backwards from the way they give it to you. But we're going to put the y number on top. I've done that for us. What is 3 divided by a half? No, not 3 times. Oh, hold on. Yes, sorry. You said 6. Okay, you're right. And by the way, a half is just 0.5. So we just divide that. What's 6 divided by 1? 9 divided by 1.5 or 1.5. You're guessing 6.
6.
Well, I need to know because if one of these is different, it's not proportional. What about 12 divided by 2? So are these proportional? Yes. And we didn't use the cross products method. We used the dividing method to figure that out. Let's do another one. Now, again, which number goes on top? The x or the y? The y goes on top. It would make more sense to say how many nails I use per birdhouse and not birdhouses per nail. It even makes sense. What's 12 divided by 1? 24 divided by 2? 48 divided by 4? 72 divided by 6? 12? This is proportional then. Yeah, that's proportional. You swim your first 4 laps in 2.4 minutes. Now a lap for those swimmers in here. How many are swimmers in here? Okay. Lap is down and back, right? Okay. So you swim your first 4 laps in 2.4 minutes. You complete 16 laps in 12 minutes. Is the number of laps proportional to your time? So let's take the first ratio they gave us and write it down because we're going to write a proportion. 4 laps in 2.4 minutes. I want to know if that's the same as doing how many laps? 16 laps in how many minutes? Yeah, now make sure when you write it the same way. If you put laps on top, you should put laps on top in the other ratio. So it says use cross products to see if they're the same. You guys have your calculators ready? What's 2.4 times 16? 38.4. What's 4 times 12? 48. Are they proportional? No, they're not. Real quick, you still have your calculus. Let's do this last one. Compare the unit rates. We're going to do laps per minute. I think that's right. You do laps per minute. You wouldn't do minutes per lap. You do laps per minute. What's so again, this is be using method 2 because it says find a unit rate. What do I do to find a unit rate?
Divide.
I divide. So this is method 2. What is 4 divided by 2.4? 0.6 repeating. Okay, and that's laps per minute. Do 16 divided by 12. Is the 3 repeating this time? Is it the 3? What's 16 divided by 12? I want to let you guys out of here if we can finish this. Is the 3 repeating? Okay. So it looks like I slowed down 1.6 laps per minute to 1.3 laps per minute. Why do you think I slowed down? Yeah, you get tired, right? Only a machine's going to swim the same pace for 16 straight laps. That's kind of, or Michael Phelps maybe in his prime. All right, we'll stop right there, and you guys are dismissed. 5.1 homework is due tomorrow, and this homework's due Monday. Monday. All the way to our